Yes, so my dear students, now we will learn about gravitation, Newton law of gravitation in this chapter. Okay. So first of all, let us discuss some of the basics. So that comes under introduction. So actually, we are all aware that whenever an object is dropped, then it falls towards Earth. If you throw a ball in vertically upward direction, ultimately it goes to some height and then again comes back to Earth. Okay, it all, they all return back to Earth. If there is a raindrop, then it is going, as soon as it leaves the cloud, it is again going to fall towards Earth. And we also find that, like, when we are going uphill, we have to do a lot of work as compared to when we are going down the hill. We have to put less effort while going down the hill. So Galileo, he was the first scientist who first recognized this fact that all bodies, irrespective of their masses, they will all fall towards Earth, and they are all going to fall with a constant acceleration, which we call acceleration due to gravity, g. And so we said that say that each body is accelerated towards Earth, and during he also found that, like, when two balls of different masses, they are allowed to fall from the same height. So both the balls, they are going to fall with the same acceleration. So this acceleration with which the bodies are going to fall towards Earth, it does not depend on the mass of the body. Okay. So during the time of Galileo, there was another nobleman called Tycho Brahe. Tycho Brahe, he spent all his life while recording observations of planets. And he was doing this observation with naked eye. He was not having any telescope. And his data was later, analyzed by Kepler. And Kepler, he formulated his laws of Kepler laws of planetary motion. He formulated Kepler laws of planetary motion. And the data which Kepler collected, he was that was collected by Newton. And Newton then proposed universal law of gravitation. He proposed universal law of gravitation. So we'll be studying about this universal law of gravitation in detail in this chapter. So first of all, we'll be studying about the Kepler laws of planetary motion. Okay. So okay, let me open a new page in this. Yes. So now let's start with the theory of planetary motion. Earlier people used to just observe heavenly bodies from Earth. They used to look at the sun, planets, etc. And they used to watch them, their movement. And The first work in the planetary motion was done by Ptolemy, and Ptolemy he was a Greek astronomer, and he gave his theory called geocentric theory of planetary motion. He gave this geocentric theory of planetary motion. So, what is the geocentric theory of planetary motion? So according to this theory, he said that all the all heavenly bodies, like suns, planets, stars, moons, etc., they are all moving. They are all moving around Earth, okay, which is stationary. Earth is something which is stationary and was taken as the and was taken as the center of the whole universe. So here, Earth was taken as the center of the universe. So this is geocentric theory. Geo means Earth. Centric means center. So Earth is the center of the whole universe, according to this theory. So this is the geocentric theory of planetary motion given by Ptolemy. And this theory was later, challenged by Copernicus. And Copernicus was then gave another theory. Now, meanwhile, in 498 AD, there was an Indian mathematician called Aryabhatta. He also did some observation and he concluded that, like various facts, like solar eclipse or moon eclipse, formation of day and night. He said that all these natural phenomena, they can easily be concluded, they can be explained by considering that Earth is revolving around the sun and Earth is also rotating about its own axis. Okay. But his idea, it could not be communicated to the Western philosophers at that time. Meanwhile, Copernicus gave his theory. So, what was the theory given by Copernicus? Copernicus came up with the idea of heliocentric theory. So, what is this heliocentric theory? So, Copernicus actually suggested that uh, the description of motion, according to Copernicus, okay, that description of motion of heavenly bodies would be simplified, would be simplified and properly explained and it can be properly explained if we assume that sun is stationary. If we assume that the sun is stationary and Earth as well as other planets, Earth as well as other planets are revolving around it, are revolving around sun. So this is heliocentric. Helio means sun. So sun is the center of the universe. So all the planets, they are all the stars, they are revolving around the sun. So this was the heliocentric theory. So now we'll be studying about the Kepler laws of planetary motion in detail. Okay.